chart. And on page 20, these properties, most of them are you've been taught, even if you don't remember, but one of them we're not going to go over because it's not too critical for what we're doing. But we're talking today about the properties of real numbers. So all the numbers that we deal with have properties. And do you guys notice those columns? What two operations are we dealing with today? What two operations? Look at those, addition and multiplication. So these properties apply to addition and multiplication. And subtraction and division, wait, they have no properties? No, those properties are tied into addition and multiplication. And hopefully you'll see that as we go on. All right, the first property I want you guys to remember is the commutative property. The commutative property. Now, there's a commutative property of addition and a commutative property of multiplication. And go ahead and look at the line, the two lines. Just look at them yourself, and you have access to that. If you need to write it, you can. So I got A plus B equals B plus A. And A times B equals B times A. What does that mean? Sarah?
Even if you switch it, it's still the same problem.
Okay, when you're adding, can you switch around the numbers when you're adding?
Yes.
Can you switch around the order when you're multiplying? Okay, so the commutative property of addition or multiplication can be summed up in the word order. The order does not affect the sum or the product. So you can multiply in any order, you can add in any order. That's commutative property. That's what you need to know. Okay, the second property is the associative property. So look at that after you write this down. Associative. The associative property. And I have, oh my, A plus B plus C equals A plus B plus C or A plus B plus C. What? And then look at the multiplication slide and tell me what that is trying to communicate to us. Okay, John?
It's about grouping, like you can group it different ways and it's sort of the same answer.
Good. The grouping of the addends or the grouping of the factors does not affect the sum or the product. So can I group two numbers and add those first, then add a third number? Yes. Or can I switch the groupings and add the last two numbers and add the first number? Yes. Same thing with multiplication. The grouping does not affect that sum. And so here's one way to, you don't have to write this down, but I'm going to write it to help some of you out. Okay, right now what's being grouped? B and C. Can I add these and then add A to it? Yes. What's being grouped on the right side? A and B. Can I add A and B first, then add C? Will I get the same sum? Yes. So that's when I change the groupings. Now, if you're looking at these properties, like especially the first one, you're like, why does it even matter? Like, why does, duh. It does matter. And I asked this question of the other class. I'm going to ask this question of different properties. Do you love the property or do you hate the property?
Like.
So we'll see. How many of you love commutative property? Love it. Okay, 5, 6, 7 maybe. Okay, how many of you hate it? Hate the commutative property. Okay, all right. How many of you love the associative property? Love it? Hate it? I hate it. Okay, so split. Oh man, sorry properties. The love is missing sometimes. All right, the next one is the identity property. And this one I am going to write out the symbols and numbers because it helps you to identify the operations being. Oh man, I did not use that in the first class. That is original to you guys.
Yeah.
I will never use it again. It didn't get the response I wanted. Okay, identity property of addition. Look at it. Look for addition. What is it trying to say? So look at that. Identity property. What does it mean?
Zero.
So for addition, any number plus 0 is itself, and for multiplication, any number times 1 is itself.
Okay, what does any number plus 0 get me? That same number. So A plus 0 gives me A. Some of you are looking at me very I don't know, critically. Yes, that's a property. And how can 0 look like? 0 can be 0, big fat O. But what else, how else is it seen at times? Yep. As nothing. If I just had A, is there an addition problem going there?
Yes.
It's A plus 0. And you're like, why? You're going to see how that applies to our solving equations, adding like terms, and today, justifying steps. Okay, and then with multiplication, it's A times, what's the identity property? 1 gets me A. So if I multiply any number by 1, what do I get? The same number. But do we always see 1 as just, the symbol 1? Or how else can we see it? How else is 1 shown? Caroline? How else is 1 disguised? Davis?
A to like the first power.
So, say that again? Ooh, so close, so close. Not A to the first power, but A to the... It's my favorite word now in math. To the 0th.
Let's go. Wait, I have another one.
I didn't know how to say it.
That's okay. A to the 0th is equal to... So what's A times A to the 0th? A, right? It's just another way of saying 1. What's another way of saying 1? Another way of saying 1. Yes, ma'am?
Isn't it just A 1?
This way? Yeah, that's 1A. Good. 1A. And we'll look at that more. Yep. What's another way of saying
number in
1?
the form of 1, so
Yeah.
1 over 1, 2 over 2.
Yeah, can 1,000 over 1,000 also be known as 1? So it's any number times 1,000 over 1,000. It's that same number, A. It could be in a different form, but does the identity change when I add 0 or multiply by 1? No, the identity stays the same. Okay, and then the next one, the inverse property. Notice inverse and identity are not the same word. That's just a plug because you don't want to mix them up. Inverse property. Look at the inverse property of addition. What's another way to replace inverse? We talked about this maybe last week. Inverse can also be known as opposite of. Okay, ready? If I take a number A and I add the opposite of A, which is negative A, what's that going to get me? Ooh. 0th. No, it's a 0. Not 0, sorry. 8 to the 0th. I'm thinking of names for my daughter. 0th?
Oh yeah.
No, 0th. 0th. Not ith. Eth. Okay. That's my daughter you're talking about. Okay, fine. It's not my daughter because I'm not calling her that because you made fun of her. No. I'm just kidding. That's okay.
You guys are so mean.
No, someone asked today, does your daughter have a name? No, I don't know the name because with Ezra and Titus it's very clear. Ezra's his name. Titus we got it a little bit later, but Titus is his name. With my daughter, it's like...
She named her Esther because they're all Bible.
Yeah. I guess I could. There are some names, but man, it's so hard to pick a girl's name. These are all good names, by the way. But it's hard. Like if I call one of your names, I'll think of you every single time. You know what I mean? It's not bad, but it's kind of strange.
Well, there's no
Not many Murphys in the world.
All right. So, yeah. But see now, I don't think Murphy. Wait, no, Murphy. Oh, I'm so confused.
There's no Esters in our grade, so
That's true. I had an Esther though as a student. Yeah, I've had almost every name that I could think of, like that I'd want to give.
Have you even tried to look up girl names?
Sorry, what are we doing? All right. Inverse property of multiplication. What's the multiplicative inverse of A? What's the multiplicative inverse of A? It's also known as the...
Opposite.
Not opposite, but the reciprocal. What's the reciprocal of A? 1 over A. So A and negative A are additive inverses. A and 1 over A are multiplicative inverses. All right, and what's A times 1 over A? 1.
What?
Look at, yeah, that's okay. What's A times 1 over A? Or isn't it, what's A over 1 times 1 over A? A over A, which gives me a big fat 1. And again, it's funny because I teach this lesson and I get what you're thinking. You're like, this is so dumb. You're wasting your time. What do we even Okay, I'm going to use this. When we get to equations, we're going to use this almost every day. At least once, maybe several times. Use this, and use that. We're going to use it all the time. And you're like, no, that's not true. We're going to use it all the time. I'll try to point it out so you can see the value of it. But right now it's kind of like, please stop, Mr. A. And I will soon. Okay, you guys okay with these? Multiplicative inverses and A over 1, and additive inverses and what their sums are or their products are. Okay, the last one we're going to talk about, dun, 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 distributive. Now, look at the chart for distributive property. Is it an addition property or a multiplication property? It's both. So here I'm going to draw it out. A times B, bless you, plus C. Okay, looking at this expression right here, what operation or operations are occurring in this expression? Addition and multiplication. Now, order of operations, wouldn't I normally have to add B plus C and then that sum gets multiplied by A? Isn't that normally what I do? Okay, that's normally what you do. But with the distributive property, what am I actually going to do first? I'm not going to add first. I'm going to multiply first.
What if you multiply A times B then A times C?
So this is what I'm going to write down. I want you guys to write it down too. A times B plus A times C. A times B plus A times C.
Is it okay if we bring them like the parentheses, so the parentheses are around A and B?
Like this? Yeah, technically, and they're going to do that too. I don't like that if it's not super necessary because now it makes it more complicated, but you can. It's not wrong. Mm-hmm. Okay, how many of you kind of get that? You're doing A times B plus A times C. You guys get that? Okay, let's see if you can get it with this. How would I write that out? A little bit different? Maybe not so different? Possibly, I hope. There's a difference. There's a difference. Okay, why?
A divided, or B divided by A.
Oh, so you're thinking it's like because of that negative sign you do something else, but it's actually a little.
Negative? I thought it was minus.
Yeah, see why these are good questions. I don't know if it's minus or negative because this is tough. Yes, I see that hand, Peter. What would you get?
I thought it would be A times B minus A.
A times B minus A times C is correct. Do you get that? You're just multiplying same things, but you're subtracting those products. Okay, but that's not the only way to write it. I'm going to write it in a weird way, but I'm going to give you a justification why I could do it that way. But questions or comments? Comments? Okay.
I want to say the other way around.
Oh, okay. Davis, yes, please. Go ahead. Yeah, what would you do? All right, listen up. I want to know.
Can it be A times B plus A times negative C?
Okay, yeah, someone else said that in the other class. I'm going to write it. You don't have to write this down, but you could say it. A times B plus A times negative C. Whoa. Back. Whoa. Yeah. Davis, why are you able to do that? Like, what's your thought process for writing that?
Or you can write that as B plus negative C.
Okay, can you write B minus C as B plus negative C? Okay, what do we do there? Stay, change, opposite. You could do stay, change, opposite, make it an addition problem. Okay, and therefore you can get it like that. I agree. Davis, you actually brought up a good point. You're all going to need to know this anyway, so I'm going to write it here. This is not distributive property, so this is like a side note. B minus C can be written as B plus negative C. Do you guys agree with that? Is that true? We're not making this up? Okay, so B minus C can be written as B plus negative C, and according to this little equation, B plus negative C can be rewritten as B minus C, right? Okay, you know why we can do that? It's not a property. It is the definition of subtraction.
Do you have to write that down?
Yes, because you're going to need to use this. So this is like it's my thought bubble, as people do. Yeah, it's a bubble. Or a thought cloud, or a thought germ, whatever it looks like. It's my thoughts. That's something you need to know. That B minus C can be written as B plus negative C, and the reason why, the definition of subtraction. So ready, guys? Here's where we're going to get deep. We're going into deep waters right now. Stay with me. What two properties are we talking about with these? What two operations are we talking about with these properties? Multiplication and addition, right? But what about subtraction and division? Like, do they not have any properties? Well, first of all, the definition of subtraction is saying that this subtraction problem is really just an addition problem. So addition and subtraction, I don't want to say the same, but they're very close, right? They're right there. You can actually define one by the other. So subtraction also has some application here. Yes, John.
So you know how a negative plus a times a positive is a negative.
A negative times a positive is a negative?
So when we were doing the distributive property and we're doing A times negative C, wouldn't it be negative AC?
So if you're talking about these being multiplied, then there's no distribution going on. Like these have to be added or subtraction, or added or subtracted.
But like with the distributive property, like aren't we multiplying?
Yep.
Yeah, so we're multiplying. So then when we go A to C, wouldn't that be negative AC?
Yeah. That's what both of these are going to get you. Negative AC or minus AC, and this will get you plus negative AC. So you will get that. Yep, you'll get that. Yes?
So in the distributive property, why do we have to write it out like that? Like I know A is being multiplied by both, but why couldn't you write like A times B plus negative C? Why do you have to write it like A times B and then separate?
Because you have to tell me that there's two multiplications going on. Like these two are being multiplied, and then these two are being multiplied. So two separate problems. Yeah, so you have to show me that, or at least write it down. Okay, these are good questions, and let's look at our application and see if you really understand it. Oh, time out. Forgot to ask your opinion. Distributive property. You either love it or you hate it. There's no middle ground. I love it. Raise your hand. Whoa, more than the other class. Two more than the other class. I hate it. So I hate it, and I hate everything about it. Okay, all right, that's fine. I was telling the other class, in my freshman speech class in college, one of the speeches you had to give was a persuasive speech. So you know, persuasive, you're trying to persuade them to think what you think, or something that you don't want them to think. You want to persuade them. So they take a vote at the beginning. I give my topic, and I want to give the topic because it's semi-controversial. So the topic was, and this is my standpoint, and they voted, and most people said, I do not agree with you, Mr. A. Two of them said, I'm not sure if I agree or disagree with you, and one of them said, I agree with you. So this means I have to try to get as many of those do not agree with yous to either move into the neutral or the I agree with you, right? That's my goal? Okay, so I give the speech, and I'm like, man, I love this topic, and I gave it. And they did a revote. So here how the revote came out. Remember the two in the middle category? They are not there anymore. They went to the I do not agree with you. But thankfully that person who agreed with me stayed. I think that was the same person. All right, one person. No. It was my classmates. Okay, so kind of like when the vote's going on, I actually went opposite of my persuasion. I'm like, wait, I don't think I did a good job. So I was kind of like down, but the teacher, I wasn't like too down, but I was kind of like, really, guys? Okay, so the teacher's like, he was writing notes the whole time because that's how they grade your speeches. And he's like, he lived during the time that I'm referring to. So I'm talking about something that happened in his time when he was younger that he actually witnessed. And he says, you know what? I never thought of it that way. Yeah, I could see what you mean by that. I was like, yes. I don't care about you guys, classmates. I care about what he says. He's grading it. No, I was a little bit upset, a little bit discouraged. But my goal isn't for you to love distributive property, or is it?
It is.
Okay, it is. Yep. And I'm gonna make up for my freshman speech. Persuasion. All right. Why? Yes, sir. No. No. It's can't do it. No, I'm kidding. It's just I don't want to do it because people start talking about it, and then we get into a debate, and no, not gonna go into. Thank you for asking.
Yeah, it was probably why Mr. A likes pet rocks.
Oh, and no one could follow me on that. Okay, anyway.
Anyone got one agreed?
And one still, which is, the weird person, add like terms. What's actually funny is my wife and I before we were married, we were engaged, and we took a class together. We're both competitive, and it was a speech class. And it was when I was in grad school, she was a senior. So it's a grad versus a senior. I'm the grad.
You lost.
Every speech I lost. She got hundreds, 99s, 98s, and I got 90s, 80s. So, and then on the test, we shared the textbook because you just buy them. We just shared it. And I had it the night before the test, and that's when I studied it. She didn't have it.
And she won.
She did better than I was like, I hate speech. I don't even like speech. So, I was upset. Anyway.
She was in school, so she was already learning. She was in the learning.
Yeah, she's a lot smarter than I am. All right, yep. They're going to call you. They'll call you. These two are like terms. Does anyone remember what the definition of like terms are? Mm-hmm.
And I'd like it's like a number with the same
variable with the same exponent. So are these two like terms? They have the same variable, and those variables have the same exponent. What's the variable of those exponents? What's the exponent of those variables? 1, not 0, right? Not 0th. That would make it different. So they both have a 1 here, right? 0th. 1th. To the 1th. Okay. So here we have like terms. They have the same variables with the same exponents. So if I did this, how would I be able to combine these two together? So it's 2a minus a. Okay, how many of you say it's 1a, or you could just say a?
You're saying add like terms, so don't we need to put it in the addition thingy?
Yeah. Actually, we're going to go over some things that you did here. All right, I asked the question, how many of you love distributive property? And 6 of you, I think, said I love it, and the rest of you said either you don't or I don't care. How are you able to combine these two together? Well, first of all, let me ask this question. How'd you get 2 minus nothing is 1? How do you do that? Oh, that's right. Yeah, there's a 1 there. Oh, okay. 2 minus 1 is 1. Oh, now I get it. Okay, but how are you able to do that? Kids, just combine those. 2a minus 1a. This is what you did. You didn't even know it. Bless you. This is what you did. Ready? Bless you. What do these two terms have in common? What do they have in common? They have an a. Now, this process I'm going through, guys, is a process that 9th and 10th graders do not here in Greenville, very close to you. I asked a student came up and was like, Mr. I took this Algebra 1 readiness thing in geometry, and no one knew what we were doing here. And then the teacher asked, and I said, yeah, I get what's going on. I don't want you to be in that I don't know category. I want you to be an I know. So look what I'm doing here. Are these two, second line, first line, the same thing?
Yes.
What property was applied? Distributive property.
Whoa.
Amazing. Now, how many of you got 1A? when you worked it out on your own? You got 1A? You know why you can get 1A?
Because it's distributive.
Because of the distributive property. You like it so much that you're guilty of not appreciating it. Have you ever been guilty of that?
Wow. See, so the people who said they like it are not lying.
Yeah, anyway, yeah, I'm going to move on before I keep getting in trouble. All right. What's 2 minus 1? See, our order of operations says you should do 2 minus 1 first, and that gives you 1. And then you would be left with that. And then how do we normally write A times 1? 1A or just A? So that's how you got it. Now, you don't have to show me these steps. You don't have to do this. But you should be able to know that the reason you can add like terms is because of which property? Distributive. It actually is more helpful.
2 minus 1 is 1.
Yep. 2 minus 1 is 1. Yep, you could say that. Okay, yes, you could have mentally just done that. Yeah, you could have mentally done that, and hopefully you guys all did do that. But the reason you can do that is because of that property. So it's not like we just make stuff up. Okay, let me give you another one. Ooh. Oh my. 3xy squared and negative 2xy squared. Are these like terms? Because they have the same variables with the same exponents. So they both have x to the first. They both have y to the second. So we're good with that. Can I combine these two together then? All right. Do it. Don't stress out too much. Okay. This is what you're doing partly on your homework. I'm going to show you what you're doing because you need to be able to justify your steps. Okay. Albert Einstein. Okay. Is he pretty bright? Yes. Was he pretty bright, I should say?
No.
Okay. He said that if you really understand a concept, some topic, concept, idea, you should be able to explain it to a 5-year-old. And if that 5-year-old gets it, you really do know it. So if you really get something, whatever subject it is, and you can explain it to a kid, not just a 5-year-old, just a kid, and they can be like, okay, I kind of get what you're saying, you really do know what you're talking about. So here, I'm going to do this, and you're going to tell me why I'm allowed to do it. And that will get us closer to explaining to anybody. All right, ready? All right, is that okay?
State change opposite.
State change opposite. Okay, if you did state change opposite, you know what you actually used?
Distributive property. Associative.
The definition of subtraction.
Oh, yeah.
Instead of subtracting, what did you do? Added the opposite. You got to know the definition of subtraction because I'm going to ask you about it several times, many times. Now and in the future. Okay. Are you guys okay with that?
No.
Yes.
Okay. So the definition of subtraction is saying when you subtract something, it's really adding the opposite. Adding the opposite. So that's the definition. We'll get more practice with that. All right, ready? This next one. What property did I use? Distributive property. Some of you are looking at me kind of confused, like, what is he doing? I'm doing what you're going to be doing. I'm doing exactly what you're going to do on at least 3 or 4 problems tonight. Well, not those numbers specifically, but you're showing me your step, giving me your reason why. Yep. Okay. Now tell me what I did. Just say you did this, or you used that property, or whatever. All right, ready? What did I do to go from this line to that line? Just tell me I did this. You did that. So you could just put add, right? And a kid will be like, oh yeah, 3 plus 2 is 5. I get it. Okay, now this next step will be my last step, and you tell me if I did it, or what did I do to get to it.
Yeah.
They were already being multiplied.
you
Okay, some of you said it. I was already multiplying, and you reordered it. So what property is that? Commutative. But Mr. A, there were parentheses there. I thought that's associative property. This is what I'm trying to emphasize. If you have parentheses, do you always have the associative property? No.
But you still multiply. It's just not a property, so we call it commutative.
Oh, yeah. Well, there's nothing else to do here. Like, you're done here. That's as simple as you can get it. So, commutative property was the last thing you did. Yep.
So, is this going to be on our number? Will you give us a problem and then we have to tell you what it is?
Yeah, let me give you the 2 types of problems you're going to get. Or 3 types. The first type's the easiest. I'm going to do this. I'm going to show you this right here. And then you have to fill in this blank. So, what did I go from here to here? Definition of subtraction. You're done with that problem. Or commutative, or distributive, whatever the case is. The second type of problem you're going to do is I'm going to work out, or the book is going to work out the whole problem for you. They give you all of this. What do you think you have to give them? Why you did each step. So you're going to write these words down. The third type of problem, they give you the problem and you write all the work and you give the definition, or you give the descriptions of what you did. Okay? There aren't many problems. And you have time this afternoon. And I will be here to help you. I have no problem with that. All right? So you're like, what do you mean by that? Okay, let's look at how many... Okay, I'm going to ask this question because I like it. How many of you still hate the distributive property? Okay, I'm going to make a deal with you right now. And you have to listen carefully to the deal. If you can fulfill these requirements, you'll never have to use the distributive property ever again. Do you understand me? Never. You're good. You're cleared from it. If you like it, then you're fine. If you do this next problem and you don't use the distributive property, you'll never have to use it again. But understand me, if you don't use the distributive property, you'll never have to use it again. Okay, here's the problem for everyone. Yeah. No, it's... Okay, I'll explain what I mean by that. All right. If you do not use the distributive property, you'll never have to use it again in your life. I promise. So do I. Ever again. Ever in your lifetime.
I got it. And I did it in my head, so it doesn't count.
Give me a few seconds here.
Does it count if you do the distributive property in your head?
So you answered the question. You said, does it count if I use the distributive property? You just gave me your answer. Like, wait, there is a way. Okay, ready, guys? Okay, this is a problem, and I want to get it simplified. I want to make it simple. So here, my first step, don't I have to go through order of operations? Okay, what's order of operations tell me to do first? Order of operations, what? M plus 9. All right, what's M plus 9? M plus 9 is? It's M plus 9. What's M plus 9? M plus 9. What's M plus 9? M plus 9. I'm in a loop. I don't know what M plus 9 is because it's just M plus 9.
No.
M plus 9. 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 M plus 9.
We could do 9m to the 0th. And so then we could do...
Whoa, there's no 0th here.
If we do n to the 0th, you can add any variable to anything.
Oh, right here, like 3m to the 0. Okay, keep going. But what do I still have to do first? Okay, m to the first, m to the 0th. Can we combine them?
But that's not distributive.
I'm in a loop in my mind.
No, that's not distributive property.
Okay, let's keep moving here. Order of operations says you have to do what's in parentheses first, so we go here. But you're like, wait, I can't make that simpler. So what property do we have to use now? And so you can do it like...
Necessarily, m to the 0th is 1. And m right there is 1m, which is 1. So that means that's m to the 0th.
I got what you're saying, but you're wrong on that little part.
0th times 3.
John, I'm sorry.
Okay, I'll wait, because if we just get behind, then we just have less time to do our work this afternoon. All right.
You can't do that even, Mr.
Oh my gosh.
You can't do 3 times m.
You just said you couldn't do none because it's in the because it's the implied m because they're not right. It's the implied and it's not m to the 0. It's multiplication. It doesn't work.
Yeah.
I'm pretty sure he's smarter than you.
No, it's not. No. It's just because I'm depending very heavily on those properties. Can I add 3 and m? No, I cannot add 3 and m. But can I multiply them? Yes. So that's what we get. And then I can multiply 3 and 9. Okay, so I get 3m plus 27, then plus 2m. Okay, what property did you use?
Distributive.
So, distributive property. All right, listen up. I'm going to show you how you're going to see it in your book and how you're going to have to work it out. Because I'm going to go, all right, I did my distributive property, now I'm left with this. And so I go back to order of operations. What do I have to do next? 3m plus 27. I have to add or subtract left to right, don't I? Order of operations? Don't I have to do that?
No.
That's not the order of operations? See, how many of you guys are wanting to do 3m plus 2m? You can do that if you switch the order of those two. 3m plus 2m plus 27. You can do that, but you have to use the commutative property. So if you're skipping around, I mean, you could do that, but you have to use you can't just like, I want to skip around. No, you're using the commutative property. All right, you guys okay with that? Like, are you okay with me doing that? Is that allowed? Yes, question.
So, if we had a problem like that, and like the order besides where it says distributive, would we have to write out where we change to the commutative and then do the addition?
Yeah, so what you're going to do is you're going to this step, and then you have to show this step. And then your next step would be, well, what's 3m plus 2m? 5m. And what did you do when you combined 3m plus 2m? You technically used, again, the distributive property, but I'm just going to have you put here, add like terms, right? Isn't that what you did? You just added like terms, and you did 3m plus 2m. Yes, ma'am?
Well, what's the easy way? You said that works, but is there a different way you do that?
So the easier way, when you're after this lesson, you can do it where you're just like, well, 3m plus 2m is 5m plus 27. You can skip this step, but what you have to know is that you actually used 2 steps to get there, even if you did it quickly in your mind. That's okay, but you have to justify it. Like a kid's going to say, wait, Mr. A, my teacher taught me you got to go 3m plus 27. And you're like, yeah, but you can just skip around. Wait, why? How can you do that? Because you just do. And you're like, wait, but why? My teacher said left to right. The teacher is 100% correct. You're correct. You have to be able to bridge it to that 5-year-old. 5-year-olds, stop doing that. You have to do this. But you can just skip around. But I have to. So what's the intermediate step? Commutative property. Can you switch the order of add-ins? You tell them?
Yes.
They're like, yeah, oh yeah, because 4 plus 3 is the same thing as 3 plus 4. Now they get it. No, actually they teach the commutative property in first grade.
And they're in K5.
And some K5s teach first grade standards. So they'll get it. They'll get it. Oh, okay. And you can explain that, I hope, pretty easily. 3 plus 4 and 4 plus 3 are the same thing, so switch them around. Anyway, add like terms. Is there anything else to do? Can I make it any simpler? What's 5m plus 27? It's 5m plus 20. I can't make it any simpler. So that's your justification. All right. Just when you thought that was it. There are 2 problems that we're going to work out. And I'm going to do them for you. All you have to do is tell me what the step is. So I'm going to write out the work. You guys write out the step. But just copy what I put down so you can reference it here. Here's the problem. 7 times y plus 2 minus 5 times y plus 8. And I want to make sure I wrote it down. 7 times y plus 2 minus 5 times y plus 8. Okay, yep. Do you have a question, Peter? Okay, this will be the last problem. All right. I'm going to write down the next step. You just copy down what I wrote. And then don't call out what I did to go from one step to the other. You just write down what I write. Okay. And don't start calling out, I'm confused, I don't get this. Just keep that to yourself. We'll try to explain it. All right, ready? This is what I'm doing. Yeah, don't call it out. Look at it. Observe the differences. The differences. The differences. And then maybe you can answer. Don't say it out loud. I'll call someone if they want to volunteer. So how to go from this first line, the given problem, to the second line. So how to go to the second step. Anyone want to guess what the difference? What the wait, DEF or DIF? Oh, sorry. Yes?
Wait, so what it is?
Yeah, what is, what's the difference, if you want?
Well, negative 5 and
So I got negative 5 here. That was a positive 5. Addition.
Because I'm stuck between two.
Okay, that's all right.
Definition of subtraction.
You would put the definition of subtraction. And I'll put it is the definition of subtraction. Yes, ma'am?
Couldn't that also be part of the associative property?
You change the groupings. Okay, so these groupings stay the same. These groupings stay the same. And then this guy right here. Okay, thank you. This guy really didn't change his grouping. He's still by himself. But yeah, I get what you're saying. Okay, next step I'm going to write out is this.
Yeah. Make sure you scrub it with soap.
All right, stay quiet, guys, so we can get this down. This one's a more difficult step.
Is that necessary?
Yes, because you're going to see it. You'll see it, so hopefully you'll be ready for that. Yeah, they're going to write it down for you like that. They're writing it down, and you write it.
This is what we're doing in our heads.
Yeah, but there's a reason why you do it. Like, yeah, and
You write all this for homework,
no. They'll give you all that. You give me just the words on this, and then I'll tell you how you do your own.
See, so we're actually
Later.
really, really smart when we do a ton of steps.
Okay,
What we do in our heads.
here, let me show you where the direct application is. Ready? All right. After this lesson, other than like your quiz or your test, I'm not going to require you to give me every justification. But how many of you have siblings or know of people who have gone through geometry? Okay, you're doing this for several chapters. You're doing this for several chapters. If I don't give it to you now, you're going to come to geometry with different topics and this stuff, and you're just going to be smacked in the face, and you're going to be like overwhelmed. No, don't be scared of this. This is what you're doing in geometry. But does anyone know what we did? Say it. All you did was a distributive property. Distributive.
But then the next property is like multiplication. So
Yeah. You just say you multiply. Yeah. You could. Right? People are like, oh yeah, you're multiplying. Yeah. So don't. Yeah. This is what you're gonna get next step. Ready? And we'll leave it here. I'll finish this up. So that made it a lot simpler.
Yeah, leave this on the board for the other one.
Okay, last step here. Does anyone know what I did? I just didn't I multiply these? I multiply those. Multiply those. You just write multiply.
Yeah. That's what happened to us last week.
Yes, remember you were just looking at it and
Yes.
I really wanted to stop.